We are in section 4 and we are simplifying rational expressions. Some of this is going to look familiar from earlier in the unit, and some of it is going to be pulling in other pieces such as factoring as we go. So if we look at number 1, this should look familiar. We have a number and a letter on top, number and a letter on bottom, and we're trying to reduce this fraction here. So if I look at my numbers, I can factor that number down into, let's say, 4 times 8, and then I might do the same thing on the bottom and factor 72 into 8 times 9. And both of those do factor farther, but in my case, since I just initially broke it down and got something similar, I'm going to be able to cancel out those 8's that were in common, leaving me with a 4 over 9. So I've reduced that fraction to 4 over 9. With the a's, I see that I really have an a to the 1 on top and an a to the 2 on bottom. 2 is larger than 1, so there's more a's on bottom. There's one more a on bottom, so I'm going to write a to the 1 on bottom and get rid of these. So my final answer is going to be 4 over 9a. Now let's jump to something a little bit different. If we go to number 6, on this problem here, we have a plus sign, and that's what makes this one unique, is the plus sign down here. If you were to see the a squared on top and bottom and say, oh, they both have an a squared, and cancel it like that, that would be completely illegal. And a quick example of why something like that doesn't work. If you imagine the fraction 4 over 8, we know that reduces to 1/2. But you could also write it as 4 over 4 plus 4, because 4 plus 4 is 8, so you could write it as the same. And if you were to think that you could just cancel like that, then really what you would be saying is that this is equal to 1/4, and we know that that's not true. So there's something about canceling through addition that just mathematically doesn't work. So we have to be careful about doing that. So instead what we're going to do is factor, because then we can turn an addition problem into a multiplication problem. So if I look at what's in common here, I see a 6 and a 12, so I see that they have a 6 in common. I see an a squared and an a, so they both have an a in common. My leftovers then, 6a squared divided by 6a is just going to be a. 12a divided by 6a is just going to be 2. So I'm going to cross that out and replace that with 6a times a plus 2. Now I've created a multiplication problem. So on the top I have a 15, and on the bottom, outside of an addition problem, I have a 6. So just outside I have a 6. And that 15 and 6, I can divide both of those by 3, giving me 5 and giving me a 2. The a squared and a, I know a squared versus a to the 1, there's one more a on top. So cross those out and just have an a to the 1 left on top. And then this a plus 2 group doesn't have a matching a plus 2 group to cancel with, so I'm going to leave that behind. So my final answer then on top is going to be 5a, and on bottom it's going to be 2 parentheses a plus 2. And if you write your final answer like this, where you keep the factored groups, the parentheses like that, that's going to be totally fine. One more example where there's a little bit more factoring is number 11. So if we look at number 11 here, we have addition and subtraction going on both the top and bottom. So we need to factor everything before we can cancel anything. I'm going to do my 3-group factoring here up on top, and there are shortcuts to factoring this. I'm going to show you the longer way that always works when you factor. So I'm going to look at my coefficients here. I have a 1 out front of x squared and a 10 out here, and I'm going to multiply a 1 and 10 to get 10. And I need two numbers that multiply to 10 and add to negative 7. So I know that 1 times 10 is 10 and 2 times 5 is 10. 2 times 5 added together equals 7. If I want negative 7, I've got to make those both negative, and as long as you switch both signs, you can do that. So I'm going to rewrite this as x squared minus 2x minus 5x plus 10. So I just split up that negative 7 there, cross that out. Factor by grouping, and I'm going to have x in common with those first two, leaving me with x minus 2. I'm going to have a negative 5 in common with the next group. Whenever there's a negative up front, I always take out that negative, leaving me with x, and then 10 divided by negative 5 is negative 2. And when you do this every single time, those two groups should be the same. So my common group is x minus 2, and my leftover group is x minus 5, the x minus 5. Cross out all those steps as I go and replace that with x minus 2, x minus 5 on top. Need to factor the bottom as well. Looking for, I have a 1 out front here, so two numbers that multiply to negative 20. 1 times negative 20 is negative 20. And I can do 1 and negative 20, 2 and negative 10, 3 doesn't work, 4 and negative 5, and I want to add up to negative 1. So this one is going to be my winner here. So I'm going to rewrite this, 1x squared plus 4x minus 5x minus 20. Factor by grouping, my common is an x plus 4 left over. My common in the second pairing is a negative 5, x plus 4 left over, because negative 20 divided by negative 5 is just a 4. And then my common group, x plus 4 out front. My leftover group, I have an x and a negative 5, so x minus 5. Cross out all these steps along the way. And when I zoom back out, I'm left with this problem. I'm left with one that has an x plus 4 group on the bottom. That doesn't match up with anything, but I also have an x minus 5 group on the bottom, and that matches up with an x minus 5 group on top. When a problem is fully factored and you have groups that entirely match, you can cross out the entire group, leaving me with this left on the bottom, this left on top. So our final answer is going to be x minus 2, x plus 4. Now if you have other tricks to be able to factor a little bit more quickly, that is absolutely fine to use, but your answer should come out the same either way. So good luck.